في خلق السماوات والأرض واختلاف الليل والنهار لآيات لأولي الألباب.
I would think about changing your perspective on the world a bit and showing you some of the designs that we have in nature. And so I have my first slide to talk about the dawning of the universe and what I call the cosmic scene investigation, that is looking at the relics of creation and inferring what happened at the beginning and then following it up and trying to understand it. And so one of the questions that I asked you is, when you look around, what do you see? Well, you see this space that's created by designers and by the work of people, but what you actually see is a lot of material that was already here being reshaped in a certain form. And so the question is, how did that material get here? How did it get into the form it had before it got reshaped, and so forth? It's a question of what's the continuity. So one of the things I look at is, how did the universe begin and shape? What was the whole process and the creation and the evolution of the universe to getting to the point that we have these kind of materials? So that's sort of part, and let me move on and show you the Hubble Ultra Deep Field. If you look in this picture, what you will see is a lot of dark with some light objects in it. And everything but four of these light objects are stars, and you can see them, they're little pluses. This is a star, this is a star. Everything else is a galaxy. Okay, so there's a couple of thousand galaxies you can see easily with your eye in here. And when I look out at particularly this galaxy, which looks a lot like ours, I wonder if there's an art design college conference going on, and intelligent beings there are thinking about, what designs I might do. And there might be a few cosmologists trying to understand where the universe itself came from. And there might even be some on that galaxy looking at ours, trying to figure out what's going on over here. But there's a lot of other galaxies, and some are nearby, and they're kind of the color of the sun, and some are further away, and they're a little bluer and so forth. But one of the questions is, that should be to you, how come there's so many galaxies? Because this represents a very teeny fraction of the sky. This is only 1,000 galaxies. We think there's on the order visible to the Hubble Space Telescope, if you had the time to scan it around, about 100 billion galaxies. Right? It's a very large number of galaxies. And that's roughly how many stars there are in our own galaxy. But when you look at some of these regions like this, you'll see more galaxies than stars, which is kind of a conundrum. So the question should come to your mind is, what kind of design, what kind of creative process and what kind of design produced the world like that? And then I'm going to tell you it's actually a lot more complicated. We're going to try and follow it up. We have a tool that actually helps us out in this study, and that's the fact that the universe is so incredibly big that it's a time machine in a certain sense. We draw this set of nested spheres cut away, so you can see it, put the Earth at the center of the nested spheres, just because that's where we're making the observations. And the moon is only 2 seconds away, so if you take a picture of the moon using ordinary light, this is the moon 2 seconds ago, and who cares? 2 seconds is like the present. The sun, it's 8 minutes ago. That's not such a big deal, right? Unless a solar flare is coming, you want to get out of the way. You'd like to have the advance warning. But you get out to Jupiter, and it's 40 minutes away. It's a problem. You hear about Mars. It's a problem communicating to Mars, because it takes light long enough to go there. But if you look out to the nearest set of stars, so the nearest 40 or 50 stars, it's about 10 years. So if you can take a picture of what's going on, it's 10 years ago. But you go and look to the center of the galaxy, it's thousands of years ago. You look at Andromeda, which is the nearest big galaxy, and it's 2 million years ago. If you took a picture of the Earth 2 million years ago, there'd be no evidence of humans at all, because we don't think there were humans yet. I mean, it just gives you the scale. And with the Hubble Space Telescope, we're looking out hundreds of millions of years to a billion years. But if we were capable to come up with an idea how to look even further, to sense things even further, and that was what I did a lot of my work, was to develop the techniques to, we could look out back to even earlier epochs before there were stars and before there were galaxies, back to when the universe was hot and dense and very different. And so that's the sort of sequence. And so I have a more artistic impression of this. There's the galaxy in the middle, which is the Milky Way, and around it are the Hubble, nearby kind of galaxies. And there's a sphere that marks the different times. And behind that are some more modern galaxies. You see the whole big picture. The beginning of time is funny. It's on the outside, right? And then there's a part of the universe we can't see because it's so dense and so hot. Light can't escape. It's like you can't see to the center of the sun. You have to use other techniques to know what's going on inside of the sun. But you can see the edge of the sun, and the universe gets that way, and you can see that. And then you see this sort of model area around the outside, and that is the radiation coming from the Big Bang, which is actually incredibly uniform. The universe is almost a perfect sphere, but there are these very tiny variations, which we show here and great exaggeration. And from them, in the time sequence, we're going to have to go from these tiny variations to these irregular galaxies and first stars to these more advanced galaxies, and eventually the solar systems and so forth. So it's a big design job, but we'll see about how things are going on. So the way these measurements were done, it's been a set of satellites, and this is where you get to see. So there was the COBE satellite, which was launched in 1989, and we discovered these variations. And then in 2000, the MAP satellite was launched, the WMAP, and it made somewhat better pictures. And later this year, this is the cool stealth version, the one that actually has some beautiful design features to it. And you see the blown up. The Planck satellite will be launched, and it will make very high resolution maps. And that will be the sequence of understanding the very beginning of the universe. And what we saw was we found these variations, and then they told us the secrets both about the structure of space-time and about the contents of the universe and about how the universe started in its original motions. So we have this picture, which is quite a spectacular picture, and I'll come back to it at the beginning, where we're going to have some mysterious process that kicks the universe off at the beginning, and we go through a period of accelerating expansion, and the universe expands and cools until it gets to the point where it becomes transparent. Then the dark ages, and then the first stars turn on, and they evolve into galaxies, and the later they get to the more expansive galaxies. And somewhere around this period is when our solar system started forming, and it's maturing up to the present time. And there's some spectacular things, and this wastebasket part, that's to represent what the structure of space-time itself is doing during this period. And so this is a pretty weird model, right? What kind of evidence do we have for that? So let me show you some of nature's patterns that are a result of this. I always think of space-time as being the real substance of space, and the galaxies and the stars just it's like the foam on the ocean. It's a marker of where the interesting waves are and whatever went on. So here is the Sloan Digital Sky Survey showing the location of 1 million galaxies. So there's a dot on here for every galaxy. They go out and point a telescope at the sky, take a picture, identify what are stars and throw them away, look at the galaxies, estimate how far away they are, and plot them up, and just put radially they're going out that way. And you see these structures, this thing we call the Great Wall, but there are voids and all this kind of stuff, and they kind of fade out because the telescope isn't sensitive enough to do it. Now I'm going to show you this in 3D. What happens is you take pictures. As the Earth rotates, you get a fan across the sky. There's some places you can't look because of our own galaxy, or because there are no telescopes available to do it. So the next picture shows you the three-dimensional version of this rotating around. You see the fan-like scans made across the sky. Remember, every spot on here is a galaxy, and you see the galaxies, sort of in our neighborhood, and you sort of see the structure, and you see this thing we call the Great Wall, and you see the complicated structure, and you see these voids. There are places where there are no galaxies, and there are places where there are thousands of galaxies clumped together. Right? So there's an interesting pattern, but we don't have enough data here to actually see the pattern. We only have 1 million galaxies, right? So we're keeping like 1 million balls in the air, but what's going on? There's another survey which is very similar to this called the 2-degree field of view galaxy redshift survey. Now we're going to fly through it at warp 1 million. And every time there's a galaxy at its location, there's a galaxy, and if we know anything about the galaxy, which you do because there's a redshift measurement and everything, you put in the type of galaxy and the color. So this is the real representation. And when you're in the middle of the galaxies, it's hard to see the pattern. It's like being in the middle of life. It's hard to see the pattern. In the middle of the audience, it's hard to see the pattern of this. So we're going to go out and swing around and look back at this. And you'll see first the structure of the survey, and then you'll start seeing the structure of the galaxies that we see out there. So again, you can see the extension of this Great Wall of galaxies showing up here. But you can see the voids, you can see the complicated structure, and you say, well, how did this happen, right? Suppose you're the cosmic designer. How are you going to put galaxies out there in a pattern like that? It's not just throwing them out at random. There's a more complicated process going on here. How are you going to end up doing that? And so now we're in for some serious play. That is, we have to seriously play God, not just change people's lives, but make the universe, right? So if that's your responsibility, how are you going to do that? What's the kind of technique? What's the kind of thing you're going to do? So